The paradox is the only thing that brings truth to light. It's not just a clever line or a trick of words, it's the ground cracking beneath what we think we know. Sometimes a question isn't there to be answered, it exists to unsettle, to disturb, to reveal the fault lines in the foundations of certainty. These are not riddles designed for amusement, nor puzzles meant to be solved. They are raw collisions between logic and the universe, places where our neat frameworks collapse and we are left staring into a void of impossibility. And somehow these contradictions have survived centuries of attempts to resolve them. Brilliant scientists, philosophers, entire civilizations have tried to smooth the edges, but the paradoxes remain, waiting, whispering, taunting. What makes them so haunting is how ordinary they look at first. You begin with something small, something obvious. A thought about time, about space, about life. It feels clear, it feels safe. But the moment you push it forward, the moment you actually follow the thread to its logical end, something shatters. Cause becomes effect. The future shapes the past. Objects exist without ever being created. Cats are alive and dead at the same time. Whole galaxies overflow with planets like ours, yet none of them seem to hold voices. Black holes erase not just matter, but the very information that describes it. Each paradox begins as an innocent idea and ends as a wound in reality itself. If you're watching this, it means you're drawn to that wound. You're not content with tidy explanations or simple reassurances. You want to see the places where the rules stop working, where science itself begins to feel less like knowledge and more like myth. You want to lean over the edge of what's possible and see how far the darkness goes, because maybe you already know the truth. The universe isn't neat, it isn't clean. It's layered, unstable, contradictory, occasionally impossible, and the fact that we can see those contradictions might mean something profound. Maybe the paradoxes aren't mistakes in our reasoning. Maybe they're glimpses of a deeper reality, one that doesn't care about our sense of order, one that thrives in tension, one that uses contradiction as its native language. This video isn't here to hand you answers. It's here to walk with you through the most fragile corridors of logic, where every step could collapse the floor beneath your feet. You'll meet civilizations that should be everywhere, and yet are nowhere. You'll confront time loops that close without ever opening. You'll watch a cat locked inside a box become both alive and dead, until your eyes decide the outcome. You'll see billiard balls collide with themselves and black holes swallow history itself. And through each of these mysteries, you'll feel the same creeping realization that reality is stranger, sharper, and more fragile than you've ever been told. If you're the kind of person who finds beauty in uncertainty, who doesn't mind staring too long into the unknown, who can carry a question like a weight without demanding it resolve, then you're in the right place, because the questions we're about to face aren't just about physics or philosophy, they're about us. About why anything exists at all, about how much of what we call real is simply habit, and about whether our search for answers is itself part of the paradox. You might leave this with more questions than you came with. You might feel smaller, stranger, or even unsettled. But maybe that's the point. Maybe the paradox isn't there to be solved. Maybe it's there to remind us that the universe was never built to fit inside our minds. The paradox is the only thing that brings truth to light. It's not just a clever line or a trick of words. It's the ground cracking beneath what we think we know. Sometimes a question isn't there to be answered. It exists to unsettle, to disturb, to reveal the fault lines in the foundations of certainty. These are not riddles designed for amusement, nor puzzles meant to be solved. They are raw collisions between logic and the universe, places where our neat frameworks collapse, and we are left staring into a void of impossibility. And somehow these contradictions have survived centuries of attempts to resolve them. Brilliant scientists, philosophers, entire civilizations have tried to smooth the edges, but the paradoxes remain, waiting, whispering, taunting. What makes them so haunting is how ordinary they look at first. You begin with something small, something obvious, a thought about time, about space, about life. It feels clear, it feels safe, but the moment you push it forward, the moment you actually follow the thread to its logical end, something shatters. Cause becomes effect. The future shapes the past. Objects exist without ever being created. Cats are alive and dead at the same time. Whole galaxies overflow with planets like ours, yet none of them seem to hold voices. Black holes erase not just matter but the very information that describes it. Each paradox begins as an innocent idea and ends as a wound in reality itself. If you're watching this, it means you're drawn to that wound. You're not content with tidy explanations or simple reassurances. You want to see the places where the rules stop working, where science itself begins to feel less like knowledge and more like myth. You want to lean over the edge of what's possible and see how far the darkness goes, because maybe you already know the truth. The universe isn't neat, it isn't clean, it's layered, unstable, contradictory, occasionally impossible. And the fact that we can see those contradictions might mean something profound. Maybe the paradoxes aren't mistakes in our reasoning. Maybe they're glimpses of a deeper reality, one that doesn't care about our sense of order, one that thrives in tension, one that uses contradiction as its native language. This video isn't here to hand you answers. It's here to walk with you through the most fragile corridors of logic, where every step could collapse the floor beneath your feet. You'll meet civilizations that should be everywhere and yet are nowhere. You'll confront time loops that close without ever opening. You'll watch a cat locked inside a box become both alive and dead until your eyes decide the outcome. You'll see billiard balls collide with themselves and black holes swallow history itself. And through each of these mysteries, you'll feel the same creeping realization that reality is stranger, sharper, and more fragile than you've ever been told. If you're the kind of person who finds beauty in uncertainty, who doesn't mind staring too long into the unknown, who can carry a question like a weight without demanding it resolve, then you're in the right place. Because the questions we're about to face aren't just about physics or philosophy, they're about us. About why anything exists at all, about how much of what we call real is simply habit, and about whether our search for answers is itself part of the paradox. You might leave this with more questions than you came with. You might feel smaller, stranger, or even unsettled. But maybe that's the point. Maybe the paradox isn't there to be solved. Maybe it's there to remind us that the universe was never built to fit inside our minds. Space looks calm, but hiding inside that silence is a question that shakes everything we think we know. We live in a galaxy with hundreds of billions of stars, and most of them are older than our sun. Thanks to modern telescopes, we now understand that many of those stars have planets, and a surprising number of them orbit in conditions that look eerily familiar, warm enough for liquid water, stable enough for life, ancient enough for intelligence to have evolved countless times over. Statistically, the numbers are overwhelming. There should not only be life scattered across the Milky Way, there should be civilizations, vast and varied, some primitive, some unimaginably advanced. The galaxy should be echoing with signals, with light, with artifacts, with signs that we are not alone. And yet, the deeper we listen, the darker the silence becomes. For decades, giant radio telescopes have scanned the skies. They've waited patiently for a whisper, a fragment, any artificial pulse drifting across space. The antennas stretch toward the heavens like open hands, ready to catch even the faintest murmur from intelligent life. But what they've recorded instead is an unbroken silence, not a single verified signal, not one undeniable trace. Just the soft hum of stars and the endless emptiness between them. It's as if we've been shouting across a canyon only to hear nothing return. Not because there's no one on the other side, but because something else is happening, something stranger. This contradiction is known as the Fermi paradox, named after the physicist who once asked a simple question during lunch: where is everybody? It highlights a truth that's impossible to ignore. By all reasonable estimates, intelligent life should be everywhere. Even if we take the most conservative numbers, the odds suggest hundreds, maybe thousands of civilizations should exist in our galaxy alone. And yet we don't see them, we don't hear them, we don't find their ruin. All we find is silence, deep and constant, stretching across the stars like a warning we can't interpret. Think about what that means. Imagine standing in a crowded city, skyscrapers rising all around you, billions of windows glowing in the night, and yet not a single sound. No footsteps, no voices, no movement, just stillness. That's what the Fermi paradox feels like. The Milky Way should be teeming with life, and yet it appears barren, like a cathedral built for worship, but abandoned before the first prayer was spoken. The contradiction cuts at something deep inside us because it doesn't just question the universe, it questions us. If the cosmos should be full of voices, then why do we seem to be the only ones speaking? There are theories, of course. Maybe civilizations rise, but fall quickly, their lifespans too short to overlap with ours. Maybe they destroy themselves before they ever reach beyond their worlds. Maybe they're out there now, listening quietly, deliberately choosing not to reveal themselves, or maybe the reality is heavier than all of those possibilities combined. Maybe we are the first. That possibility changes everything. It makes humanity fragile and rare. It means we're not just searching for others. We're carrying something that might not exist anywhere else. A chance to speak when no one else has spoken. A responsibility not to vanish before our voice is heard. The silence is not just empty, it's sharp, deliberate, unsettling. And the more we learn about how full the galaxy should be, the more unnatural that silence feels. Because silence this deep doesn't just suggest absence, it suggests a mystery, one that could change how we see life, intelligence, and our own place in the cosmos. And as we stare into that silence, one thought lingers. Maybe the question isn't whether someone else is out there. Maybe the real question is why the universe wants us to feel so alone. Space looks calm, but hiding inside that silence is a question that shakes everything we think we know. We live in a galaxy with hundreds of billions of stars, and most of them are older than our sun. Thanks to modern telescopes, we now understand that many of those stars have planets, and a surprising number of them orbit in conditions that look eerily familiar: warm enough for liquid water, stable enough for life, ancient enough for intelligence to have evolved countless times over. Statistically, the numbers are overwhelming. There should not only be life scattered across the Milky Way, there should be civilizations, vast and varied, some primitive, some unimaginably advanced. The galaxy should be echoing with signals, with light, with artifacts, with signs that we are not alone. And yet, the deeper we listen, the darker the silence becomes. For decades, giant radio telescopes have scanned the skies. They've waited patiently for a whisper, a fragment, any artificial pulse drifting across space. The antennas stretch toward the heavens like open hands, ready to catch even the faintest murmur from intelligent life. But what they've recorded instead is an unbroken silence. Not a single verified signal, Not one undeniable trace, just the soft hum of stars and the endless emptiness between them. It's as if we've been shouting across a canyon only to hear nothing return. Not because there's no one on the other side, but because something else is happening, something stranger. This contradiction is known as the Fermi paradox, named after the physicist who once asked a simple question during lunch: where is everybody? It highlights a truth that's impossible to ignore. By all reasonable estimates, intelligent life should be everywhere. Even if we take the most conservative numbers, the odds suggest hundreds, maybe thousands of civilizations should exist in our galaxy alone. And yet we don't see them, we don't hear them, we don't find their ruins. All we find is silence, deep and constant, stretching across the stars like a warning we can't interpret. Think about what that means. Imagine standing in a crowded city, skyscrapers rising all around you, billions of windows glowing in the night, and yet not a single sound. No footsteps, no voices, no movement, just stillness. That's what the Fermi paradox feels like. The Milky Way should be teeming with life, and yet it appears barren, like a cathedral built for worship, but abandoned before the first prayer was spoken. The contradiction cuts at something deep inside us, because it doesn't just question the universe, it questions us. If the cosmos should be full of voices, then why do we seem to be the only ones speaking? There are theories, of course. Maybe civilizations rise, but fall quickly, their lifespans too short to overlap with ours. Maybe they destroy themselves before they ever reach beyond their worlds. Maybe they're out there now, listening quietly, deliberately choosing not to reveal themselves. Or maybe the reality is heavier than all of those possibilities combined. Maybe we are the first. That possibility changes everything. It makes humanity fragile and rare. It means we're not just searching for others. We're carrying something that might not exist anywhere else. A chance to speak when no one else has spoken. A responsibility not to vanish before our voice is heard. The silence is not just empty. It's sharp, deliberate, unsettling. And the more we learn about how full the galaxy should be, the more unnatural that silence feels. Because silence this deep doesn't just suggest absence, it suggests a mystery, one that could change how we see life, intelligence, and our own place in the cosmos. And as we stare into that silence, one thought lingers. Maybe the question isn't whether someone else is out there. Maybe the real question is why the universe wants us to feel so alone. Not long ago, Earth was thought to be a rare exception. A fragile blue dot circling a modest star, unique and possibly alone. That illusion has collapsed. Modern telescopes like Kepler and TESS have shattered it, revealing that our galaxy is overflowing with planets. Not a few, not thousands, but billions. And among them, Earth-like worlds aren't the rarity we once imagined. They're common. Data from the Kepler mission confirmed that across the Milky Way, there may be more than 300 million rocky planets orbiting in the habitable zones of sun-like stars. Hundreds of millions of places where oceans could glisten, where sunlight could nurture biology, where time could patiently sculpt intelligence. Even if only a small fraction of those planets ever saw life emerge, the numbers still demand that we shouldn't be alone. And yet, when we look outward, what we find isn't proof of neighbors, it's silence. This is where the contradiction becomes unbearable. The math insists that civilizations should exist in vast numbers. Even with the most pessimistic assumptions, the equation doesn't collapse to zero. The odds say someone, somewhere, should be out there, and not just faint traces hidden in distant galaxies, but right here, within our own Milky Way, close enough that their signals should already be washing over us. Radio waves travel at the speed of light. A civilization that started broadcasting 1 million years ago would have filled half the galaxy with its voice by now. If even one civilization endured long enough, we should be swimming in signals, surrounded by whispers, echoes, conversations layered across the spectrum. But instead, the cosmos is quiet. The contradiction cuts deeper every time we discover a new planet. The more habitable worlds we find, the stranger the silence becomes. Think of it like walking into an endless library. Shelf after shelf stretches beyond sight, each lined with books. By sheer numbers, the library should be full of stories overflowing with words. And yet, every book you open is blank. The math says the shelves should be heavy with meaning, but the pages refuse to speak. That's what Kepler's discoveries feel like. Confirmation that the universe is a library so vast it should echo with voices. But in practice, every star is a silent volume, unopened, unread. The Fermi paradox was unsettling before, but now, in light of this data, it becomes something sharper. It's not just that we can't find evidence of intelligence, it's that the very abundance of planets makes that absence more unnatural. Each discovery doesn't soothe the mystery. It inflames it, because every new Earth-like world is another stage that should have hosted life, another chance for intelligence to emerge, another opportunity for voices to rise and reach into the stars. And yet none have. It's like walking into a crowded arena, seeing every seat filled but realizing the silence is absolute. No movement, no sound, no presence, just an audience that looks alive but refuses to breathe. Some argue this contradiction reveals something profound about the nature of life. Maybe it isn't as inevitable as we think. Maybe biology doesn't climb easily toward intelligence. Maybe technology doesn't last, or maybe there's a filter, some barrier that wipes civilizations away before they ever get the chance to speak. The numbers don't just raise questions, they demand answers, and none of them feel safe, because every solution we propose comes with a shadow. If life is rare, then we are an impossible accident, fragile beyond belief. If civilizations fall quickly, then our survival is uncertain. If someone is out there but remains hidden, then perhaps they have reasons that we're not ready to face. The Kepler data was supposed to bring us closer to others, to narrow the gap between hope and evidence. Instead, it widened it. Now we don't just wonder where everyone is, we wonder why the universe has gone to such lengths to make it look like they should be here. And in that gap, between probability and reality, something ominous begins to take shape. Because if the galaxy is truly full of potential voices, then silence might not be natural. Silence might be strategy. If the galaxy is overflowing with worlds where life could thrive, then silence stops feeling natural and starts to feel deliberate. That's where one of the most unsettling ideas comes in. A theory that doesn't just explain the silence, but makes it terrifying. It's called the dark forest hypothesis, and it imagines the universe not as an empty stage waiting for voices, but as a hunting ground where every civilization is both predator and prey. In a dark forest, every step, every sound, every flicker of movement is a potential death sentence. You don't shout, you don't sing, you don't announce your presence. You hide, because if you reveal yourself, you might not live long enough to regret it. The same logic, applied to the cosmos, paints a chilling picture. Maybe the reason we haven't heard from anyone is because the moment you reveal yourself in this vast darkness, you don't survive. Think about the position of a civilization just starting to reach into the stars. They don't know who's out there. They don't know if the others are peaceful or hostile. They don't know if the first signal they send will bring friendship or annihilation. What they do know is that the safest strategy is silence. Stay hidden. Listen, but never speak. Watch, but never move. Because in a universe where you can't know the intentions of strangers, the risk of being seen is catastrophic. A single mistake, a single broadcast, could give away your location to something unimaginably advanced. And in that case, the silence we hear isn't emptiness, it's survival. This idea turns the galaxy into something almost unbearably tense. Billions of civilizations could be out there, each one alive, awake, intelligent, and each one silent. All of them listening carefully, all of them waiting, all of them terrified to be the first to make a sound. If one slips, if one shouts into the dark, it might disappear before anyone else even hears. Suddenly, the silence we've been struggling to explain becomes inevitable. The absence of voices isn't because there are none, but because none dare to speak. It's a grim thought, but it fits. It explains why the numbers point toward abundance, yet the evidence points toward emptiness. It explains why we find no signals, no beacons, no obvious signs of galactic empires. It's not that they don't exist, it's that they've all learned the same lesson: to survive, you stay invisible. And if that's true, then Earth is in a precarious position. For over a century, we've been leaking radio waves into space, announcing our presence without thinking about who might be listening. To us, they're harmless broadcasts, old sitcoms, news reports, navigation signals, but to someone out there, they're evidence. A flare in the forest, a movement in the trees. And if the dark forest is real, that could be enough. What makes this idea so haunting is that it flips the way we see the stars. No longer distant, indifferent suns, they become potential eyes, watching quietly. Civilizations vast and ancient might be observing us right now, judging whether we're clever enough to stay silent or foolish enough to shout. And the most chilling part is that if they are watching, we would never know. They could be hidden behind technology we can't even imagine, their silence deeper and more deliberate than ours could ever be. The dark forest hypothesis doesn't just suggest danger, it suggests inevitability. If the galaxy works this way, then every civilization eventually learns to hide. The ones who don't vanish, erased before they can leave a trace. The ones who survive leave behind only silence. Which means the quiet sky above us isn't empty, it's crowded. But every presence is cloaked, every voice swallowed, every intelligence locked in a prison of its own fear. And as we continue to listen and hear nothing, the silence becomes less comforting and more like a warning. Because if the dark forest is real, then every day we continue to exist without being erased is luck, and luck eventually runs out. The dark forest hypothesis paints the universe as dangerous, crowded with hunters hiding in the shadows. But there's another possibility, one that is in many ways even heavier. What if the silence isn't camouflage? What if it isn't strategy? What if it's the truth? Imagine standing on the shore of a vast ocean. Waves stretch to the horizon, the water gleams under starlight, and every instinct tells you this sea should be alive. Fish should be darting beneath the surface, whales should be rising to breathe. Something should be moving in all that water, but when you listen, when you wait, you hear nothing. The water is still, the ocean is empty. That's what the silence of the universe begins to feel like. Not the hush of hidden civilizations, but the absence of them altogether. No watchers, no voices, just us, speaking into a void that was never meant to answer. This is the possibility that we are truly alone, not because others are hiding, but because they never existed. The galaxy may be overflowing with planets, the conditions for life may be common, but the spark itself could be impossibly rare. Maybe the chain of events that led to life on Earth, the delicate chemistry, the improbable stability, the exact accidents that allowed us to evolve, wasn't just unlikely. Maybe it was nearly impossible, and if that's true, then we aren't latecomers to a crowded party. We're the first guests to arrive at a celebration that may never happen. The silence isn't ominous, it's sacred. It means we are something fragile, something singular. The weight of this idea is staggering. If we are the first, then we carry not just our own survival, but the survival of intelligence itself. We're not just searching for others, we are the others. We're the voice that might one day echo across the galaxy, the example that will either endure or vanish before anyone else can follow. To fail in that role would mean more than extinction. It would mean the universe losing its first experiment in awareness. We aren't just another species among many. We could be the prologue to all of consciousness, or its final chapter before the story ever had a chance to unfold. And when you sit with that thought, the silence changes. It stops being suspicious. It stops feeling like a trap. It becomes a mirror. Every time we look out and see nothing, what we're really seeing is the responsibility staring back at us. If no one else has spoken, then it falls to us to keep speaking. If no one else has survived, then it falls to us to endure. If no one else exists, then every decision we make, every action we take, weighs heavier than we realize, because we aren't just shaping our own future. We may be shaping the only future intelligence will ever have. This idea doesn't comfort, it unsettles, because to be first is to be unprepared. To be first is to be fragile. To be first is to stand at the edge of an untouched wilderness, knowing every step you take is one no one has taken before. And yet, there is a strange beauty in it too, because if we are the first, then the silence isn't a warning, it's an invitation, a blank canvas, as wide as the galaxy, waiting for us to decide what kind of story will be written here. But that invitation comes with a question more terrifying than any hidden predator. Can we survive long enough to accept it? Can we resist destroying ourselves before we've even begun? Can we bear the weight of being the first and maybe the only? These aren't just scientific questions, they're existential. And if the silence really does mean emptiness, then every mistake we make matters more than we can possibly comprehend. Time feels like the most stable thing we know. Seconds pass, days end, causes lead to effects, and history unfolds in a line we can trace backward to its beginning. But beneath that rhythm, something unsettling hides. Physics doesn't always demand that time run forward like a river. In fact, some of the equations suggest time can bend, circle, even feed back into itself. Imagine a loop, not as a metaphor, but as a literal structure. You take something from the future, bring it into the past, and that very thing becomes the reason it exists. There's no origin, no first cause, just an endless cycle repeating itself forever. This is the foundation of one of the strangest ideas in science, the closed time loop, where the effect creates the cause and the cause creates the effect. A paradox that doesn't just stretch logic, it breaks it. Picture walking into a bookstore and finding a copy of Hamlet. You buy it, read it, and years later, after building a time machine, you travel back to Shakespeare's London. You hand him the book, and he copies it word for word, publishing it as his own. Centuries later, that exact book ends up in the same shop where you once bought it. Who wrote it? No one, and everyone. The loop contains the story, but the story has no beginning. It exists because it exists. A circle feeding itself. This kind of paradox isn't just a thought experiment. Einstein's equations of relativity allow for solutions where time flowed back on itself in this exact way. Rotating black holes, wormholes, certain geometries of space-time, they all leave open the possibility of loops where cause and effect blur into one. The strangeness doesn't stop with literature. Think of technology. What if someone one day receives a blueprint from the future, builds it, and then becomes the person who sends it back. The invention has no origin. It was never created, only passed around a loop that sustains itself indefinitely. Knowledge without a creator. A machine without an inventor. Information untethered from the arrow of time. These loops strip away something fundamental. The idea that everything must come from somewhere. And once you start to question that, you realize how fragile our sense of reality really is. But loops aren't just about objects or stories. They touch existence itself. If time can circle, then perhaps even our lives aren't as linear as they seem. Perhaps some moments aren't beginnings or endings at all, but folds we've passed before. It makes progress feel like memory. It makes invention feel like recollection. It turns the timeline into something less like a road and more like a spiral staircase, always climbing but always circling the same points again. And if that's true, then how much of what we believe to be original, our ideas, our choices, even our very selves, might actually be echoes from loops we can't see? The paradox deepens when we try to imagine free will inside these loops. If the future is responsible for the past, then how much of what we call choice is actually predetermined? If you handed Shakespeare Hamlet, he could not write it. If you received the blueprint, you couldn't not build it. The loop demands completion, consistency, and in doing so, it robs you of alternatives. That's why some physicists argue that if time loops are real, then the universe must enforce a principle of self-consistency. Events can fold, but they can't contradict. You can go back, but you can only ever do what already happened. Try to change the story, and the story bends you back into place. This doesn't just challenge our understanding of time. It challenges our understanding of existence itself. We build our lives on the idea that everything begins somewhere, that thought emerges from minds, that machines emerge from builders, that lives emerge from birth. But in a loop, beginnings dissolve. Existence becomes its own justification, and that thought is heavier than it seems. Because if time can do this, if loops like these are even possible, then maybe the universe itself is not a straight line from a big bang to an eventual end. Maybe it's a circle, an endless pattern that has no first spark because it never needed one. At the heart of physics lies a scale so small it should be simple, but instead it's where reality itself begins to unravel. Quantum mechanics doesn't just describe the tiniest building blocks of existence. It unsettles everything we think we know about how the world works. At this scale, particles don't behave like solid objects, following predictable paths. They exist in overlapping possibilities, smeared across space, neither here nor there, until something forces them to decide. The most famous thought experiment to capture this strangeness is Schrödinger's cat. Place a cat in a sealed box with a radioactive atom, a vial of poison, and a mechanism triggered if the atom decays. The rules of quantum physics say that until you open the box, the atom is both decayed and not decayed. And because the cat's fate is tied to that atom, the cat itself exists in two states, alive and dead at the same time. Only when you look, only when you observe, does one reality snap into place and the other vanish. This is not just a trick of language, it's what the mathematics demands. Before observation, particles are described by wave functions that hold every possible outcome. Observation collapses the wave, erasing the other possibilities, leaving behind only the version we see. But what if the collapse itself depends not just on a measurement, but on the presence of consciousness? That idea, still controversial, still debated, suggests something unnerving, that reality doesn't fully exist until it's observed, that the act of looking doesn't just reveal the world, it creates it. In that light, every moment becomes heavier. Every choice, every glance, every decision could be part of what forces the universe into a definite state. Without observers, maybe there's no reality at all, just endless possibility, waiting. The strangeness doesn't stop there. In the famous double-slit experiment, when particles are fired at a barrier with two openings, they create an interference pattern, as if each particle passed through both slits at once, like a wave. But the moment we observe which slit it travels through, the wave behavior collapses, and the particle acts as if it only went through one. Observation changes the outcome, not after the fact, but as if the universe rewrites itself to remain consistent with what we chose to measure. It raises a question we still don't know how to answer. Does the particle know it's being watched, or is reality itself fundamentally tied to the act of being observed? Even more disturbing is the thought that these rules don't just apply to particles in labs. If quantum mechanics is the foundation of reality, then everything, stars, galaxies, life, even us, sits on this same strange bedrock. Somewhere deep inside our own existence, we may be entangled with possibilities we'll never see, possibilities that vanish the moment we become aware. It suggests a world that isn't solid, but probabilistic. A world that only becomes definite when forced to, as if it resists being pinned down. Some interpretations try to escape this by saying that nothing truly vanishes, that every possibility remains real, branching off into alternate worlds. In one, the cat lives. In another, the cat dies. In one, you look left. In another, you look right. Each observation doesn't collapse reality, it fractures it, splitting universes like shards of glass. If that's true, then we're not collapsing waves, we're spawning worlds endlessly. Every moment, every choice, every observation becomes the seed of a new universe. And while we only see one branch, all of them exist, equally real, equally true. That idea solves the paradox, but at the cost of making reality infinite and splintered. Either way, the paradox refuses to vanish. Whether reality only exists when we look at it, or whether it splits into countless unseen worlds, the conclusion is the same. The universe isn't what it seems. It's not stable, not certain, not fixed. It's a shifting stage, shaped by possibility, constrained by observation, and maybe even dependent on us. And if the smallest scale is this strange, then what does that mean for the larger ones? If a cat can be alive and dead, if particles can exist in two states at once, then perhaps distance itself isn't what we think it is. Perhaps connection can stretch across the universe in ways that defy space and time. Take two particles, born together in the same moment under the same conditions, and then separate them. One drifts left, the other right. You could place entire galaxies between them, light years of emptiness, yet somehow they remain linked. Measure one, and the other responds instantly, as if no distance existed at all. This is quantum entanglement, and it might be the strangest discovery in all of physics. Einstein called it spooky action at a distance, because it defies everything our intuition tells us about how information should behave. Nothing should travel faster than light. No signal should leap across space instantaneously, but entangled particles don't seem to care. They behave as one system, no matter how far apart they are. What makes this so unsettling is that experiments keep proving it's real. Over and over, physicists have tested it, hoping to find some hidden mechanism, some buried variable that explains the synchronicity. But every time, the results say the same thing. There are no hidden messages. There are no secret signals. The universe itself is non-local, meaning separation is an illusion. In some deep sense, distance doesn't exist the way we think it does. What happens here can shape what happens there, not through a signal sent across space, but because the two places were never truly separate to begin with. It's tempting to dismiss this as a trick of particles, a quirk of physics too small to matter. But if entanglement is a fundamental rule of reality, then it doesn't just belong to electrons and photons. It belongs to everything. Atoms, molecules, systems, perhaps even minds. What if every interaction, every touch, every shared moment leaves behind a kind of entanglement, an invisible tether that links us in ways we can't see? If that's true, then the space between us is thinner than it feels. Separation is less absolute. Perhaps we are all already connected, woven into a fabric that doesn't care about miles or years. Entanglement also pushes us back toward one of the deepest paradoxes of all: information. If two particles can stay linked across light years, then what does that mean for the flow of knowledge in the universe? Does information truly need to travel, or has it always been shared, always been whole? With distance as nothing more than an illusion, our minds project onto a deeper unity. If the cosmos itself is built this way, then the boundaries we draw between here and there, between now and then, might be thinner than paper. And yet, for all its strangeness, entanglement may not be the most unsettling paradox it points toward. Because if two particles can remain bound across space, then what happens when the most extreme objects in the universe, black holes, get involved? A black hole doesn't just swallow matter, it swallows information. According to relativity, everything that falls in is lost forever, erased from the universe. But according to quantum mechanics, information can't be destroyed. These two truths clash violently, and at their center lies one of the deepest paradoxes in science: the black hole information problem. If entanglement shows us that distance is an illusion, then black holes force us to ask a darker question. What if forgetting is too? Imagine throwing a book into a fire. The pages curl, the words vanish, but the information isn't truly gone. In principle, if you could track every molecule of smoke and ash, every photon of heat, you could reconstruct what was lost. Physics depends on this rule. Energy transforms, matter rearranges, but information survives. Nothing is erased. Now picture a black hole. You drop something in a book, a spaceship, a planet, even a person, and once it crosses the event horizon, it's gone. No signal escapes, no hint returns. To an outside observer, the black hole grows heavier, slightly more distorted, but everything about what fell in is sealed away. The story, the structure, the information disappears. And here is the paradox. General relativity says the information is lost forever, while quantum mechanics says information can never be destroyed. Two of the most successful theories in physics collide, and the universe refuses to choose. This is the black hole information paradox, and it's one of the deepest wounds in science. If black holes erase information, then the laws of quantum mechanics are broken, and with them, much of what we know about reality. But if information is preserved, then relativity's picture of black holes is incomplete, hiding some mechanism we have yet to see. Neither option feels comfortable, and both suggest our current understanding of the universe is missing something fundamental. It's not just a question of astrophysics, it's a question of truth. If information can die, then so can memory, so can meaning, so can the fabric of identity itself. Decades of argument have followed, each more unsettling than the last. Some physicists suggest that the information is somehow smeared across the event horizon, encoded in ways we don't yet understand. Others argue that it leaks back out slowly, hidden in the radiation that black holes emit as they evaporate, a whisper carrying fragments of what was lost. Still others believe the information isn't lost at all. It's duplicated, stored in some hidden layer of reality beyond our reach. But each of these answers comes with its own contradictions, its own dangers, its own paradoxes, and none has resolved the conflict completely. What makes this so haunting is how personal it feels. The black hole doesn't just threaten stars or galaxies, it threatens the idea that the universe itself is coherent. If a book can be erased completely, then so can a life. If information can fall past an event horizon and vanish, then perhaps even the universe has places where meaning dies, where truth collapses, where history itself is forgotten. That possibility is darker than destruction, because destruction transforms, but forgetting erases. It leaves nothing behind, not even a shadow. Hawking radiation deepens the paradox. If black holes slowly evaporate over eons, radiating away their mass, then eventually they vanish completely, gone without a sound, no explosion, no trace, just silence. If the information they once consumed doesn't return with that radiation, then it's gone forever, and the universe has torn out entire pages of its own book. But if the information does return, then we need a new physics capable of explaining how. Either way, the paradox doesn't fade, it sharpens. The black hole information paradox isn't just about the fate of matter, it's about the fate of knowledge. It's about whether the universe remembers itself or forgets. And if the universe can forget, then what does that mean for us, for everything we build, for everything we dream? Maybe someday, all of it could fall past a horizon, erased not only from sight, but from existence. The thought leaves a silence heavier than space itself. Because if even memory can die, then nothing is safe, not truth, not history, not us. From the beginning, this journey has carried us through silence and contradiction, from the vast stillness of the stars to the smallest fractures in reality itself. We've asked why the galaxy overflows with worlds yet offers no voices, why time sometimes loops without origin, why particles can be alive and dead at once, why two objects light years apart can act as one, and why black holes threaten to erase not just matter, but the very information that defines existence. Every paradox we've faced has unsettled more than it explained, and yet together they reveal something deeper. They remind us that the universe is not neat, not simple, and not bound by the categories our minds want to impose on it. It's a place where logic falters, where certainty dissolves, and where the most powerful truth may be that not everything can be resolved. The Fermi paradox leaves us wondering whether we are early, alone, or simply too fragile to survive long enough to meet others. Time loops tear apart our sense of beginnings, suggesting that some stories never had an author, that some ideas never had an inventor, that maybe even existence itself is less an act of creation and more an eternal cycle. Quantum mechanics pulls the ground out from under our feet, insisting that reality does not exist until it is observed, or worse, that every possibility exists and every choice spawns a universe we'll never see. Entanglement shows us that distance may be an illusion, that the cosmos itself is stitched together in ways we can't fully grasp. And the black hole paradox forces us to ask the heaviest question of all: does the universe remember, or can it forget? These are not abstract puzzles, they are fractures that run through the very core of reality. And yet, beneath all of them, there is one paradox greater than the rest. You, a temporary creature built from stardust, aware of your own fragility, staring out at a cosmos that may never answer back. You are made from particles that obey the strangest rules in physics, and yet you think, you wonder, you dream. The atoms in your body were forged in ancient stars, scattered by explosions, recycled through galaxies, carried into the chemistry of life, and somehow arranged into a mind capable of asking questions the universe itself might not be able to resolve. You are the contradiction, the impossible outcome, the paradox the cosmos created without explanation. So maybe that's the point. Maybe the silence of the galaxy, the loops of time, the strangeness of quantum mechanics, and the mystery of black holes are not barriers to understanding, but invitations to look deeper, to accept that answers may not come neatly wrapped, that certainty may never arrive, but that the act of asking is itself a kind of meaning. The universe may be layered, unstable, even impossible at times, but we are part of it. We don't stand outside these paradoxes, we are woven into them. And if the cosmos can hold contradictions this vast, then maybe our questions are not failures. Maybe they're the truest reflection of what it means to exist at all. In the end, the silence isn't empty. It's full of weight. The paradoxes aren't mistakes, they're signals. They remind us that the universe doesn't owe us clarity, but it does allow us wonder, and wonder may be the most powerful force we have. Because even if time circles, even if reality splits, even if black holes forget, we are here, now aware. The impossible happened once, and it's happening in you. And maybe the final paradox isn't hidden in the stars or buried in equations. Maybe it's that the universe made something that can look at itself and ask why.